Welcome to the Deep Dive. This is where we take the sources you're interested in, dive deep, and pull out the key insights. It's basically a shortcut to getting up to speed.
Yeah, think of it as your personalized knowledge boost.
And this time, you pointed us towards David Deutsch's The Beginning of Infinity. Wow. This book goes everywhere from, the universe itself to how we actually think.
It really does. It's ambitious stuff.
Yeah.
So our mission today, based on the book, is to explore how knowledge is created, how it grows, and what that tells us about, well, reality. We want to hit those aha moments you asked for, but keep it clear, not overwhelming.
Okay, let's jump in. The book starts with something pretty fundamental, the scale of the universe, like when we just look up at night.
Right, you see dots, maybe a few thousand on a clear night. But an astronomer, using their knowledge, sees something totally different.
Yeah, those dots become stars, massive nuclear furnaces, light years away. Our sun's just one of them, pretty average, actually.
Exactly. And we even understand how they work in nuclear fusion. Hydrogen smashing into helium, releasing all that energy. It's not magic, it's physics.
And the scale just keeps expanding. Deutsch mentions that gamma ray burst back in 2008, billions of light years off.
Halfway across the observable universe, practically.
And it was so powerful, it was visible with the naked eye. That's just hard to grasp.
It really hammers home the point, doesn't it?
Yeah.
There's just so much out there, phenomena we're only beginning to understand. An infinity of potential knowledge.
Which connects to another big idea, getting rid of this notion that we're somehow the center of everything, the anthropocentric view.
Yes, Deutsch is very clear on that. The patterns in the stars, the planets moving, they don't have any special meaning for human affairs.
Unlike, ancient myths or astrology trying to link everything up there to us down here.
We now know the universe doesn't revolve around us, not literally and not figuratively either.
And if you imagine going out there into intergalactic space, what's it like?
Vast, dark, and incredibly cold, like 2.7 Kelvin.
Which is almost absolute zero.
Pretty much. Just the leftover heat from the Big Bang. Yeah. And that has huge implications for resources, for life. It's not a friendly place.
So that image of Spaceship Earth, this cozy little self-contained home, it kind of deflates.
It does. And he also tackles the principle of mediocrity, the idea that we're just sort of average.
But he argues we're not average in one crucial way.
Exactly. Our ability to create explanatory knowledge, to understand things and solve problems using our minds, that's unique as far as we know.
So we're not limited by finite resources in the same way or by being mediocre. Our potential reach comes from knowledge.
That's the core idea. It's a much more optimistic take. Problems are inevitable, sure, but crucially, he argues they are soluble.
With the right knowledge.
With the right knowledge, that's a constant refrain. Problems are soluble.
Okay, so tiny physical footprint, potentially huge intellectual reach. How does that knowledge creation actually happen? He really goes after empiricism, doesn't he? The idea that it all just comes from our senses.
Right. The question is, where do scientific theories actually come from? Are they just read off from observations? Deutsch says no.
They're bold conjectures.
Yeah.
Ideas we actively create.
Yes, we don't start as a blank slate, a white paper. We have innate capacities, expectations, and we create explanations. Experience is vital, but it's for testing and refining those conjectures, not the source of them.
And that connects to his critique of inductivism, the common sense idea that the future will just be like the past.
Yeah, it feels right. But think about it. Flying, nuclear power, even sunrise, its frequency changes if you're in orbit. These things were often understood or predicted by theory before we experienced them.
So theory often leads the way.
In many crucial cases, yes. It's not just about predicting, it's about explaining. And that leads to the importance of good explanations.
What makes an explanation good, in his view?
It has to be hard to vary.
Hard to vary, meaning?
Meaning all its parts are essential, they play a specific role, and if you change details arbitrarily, the whole explanation breaks down or becomes much worse.
Okay, like his example of the seasons. The Earth's tilt, the orbit, you can't just swap those out easily. They're connected and testable.
Exactly. Compare that to the myth of Persephone causing winter because her mother is sad. You could change the god, the emotion, the reason.
Yeah.
It's easy to vary because it's not constrained by reality in the same way. It doesn't really explain anything deeply.
It's arbitrary, like taking a part out of a bicycle. If you remove the chain, it just doesn't work. The parts have necessary functions.
Good analogy. That's the essence of a hard-to-vary explanation. And the engine driving the improvement of these explanations, the reason knowledge started accelerating was the Enlightenment.
Not just the science, but a shift in values.
A fundamental shift. Things like tolerance of dissent, skepticism towards dogma, embracing criticism and change. That created the environment for rapid progress. It wasn't just about experiments. It was a new way of thinking about knowledge.
So criticism is key.
Absolutely. Testing predictions finds flaws. But the search for better, deeper explanations is what really drives science forward, according to Deutsch.
Okay, let's talk about observation then. He says appearances can be deceptive and all observation is theory-laden. What's that mean?
Well, take his example of astronomers looking at those glass photographic plates from the Palomar Sky Survey.
Right, through microscopes.
Yeah. What they see is maybe a tiny smudge of silver grains.
Nah.
But what they interpret it as is an entire galaxy, millions of light years away. That interpretation depends entirely on a huge body of existing theory about light, telescopes, distance, cosmology.
So you're never just seeing raw data. Your existing knowledge shapes what you see.
Precisely. And instruments, funnily enough, even though they might physically distance us, like looking at data on a screen instead of through an eyepiece,
They actually get us closer to reality. Seems weird.
because they let us see things totally beyond our senses.
Yeah.
Radio waves, X-rays, gravitational waves, they make the imperceptible perceptible. They reveal deeper layers of reality.
And when errors happen in science, it's not just a bad measurement.
It's a mistake in our explanation of the cause. Our theories are what allow us to spot biases, correct errors, and figure out what's really going on.
This leads nicely into the idea of design. Paley's watchmaker analogy is famous.
Right, the argument that something complex like a watch must have had a designer, like a watchmaker,
But then Darwin comes along.
and provides the mechanism. Evolution by natural selection. Variation and selection can produce incredible complexity biological design without any conscious designer involved. Knowledge created by evolution itself, in a way.
And Deutsch points out Paley's argument kind of eats itself, right? If complexity needs a designer, wouldn't the designer also need a designer?
Exactly, it leads to an infinite regress. He also mentions the modern view, neo-Darwinism, where it's really about genes replicators being selected for their ability to get themselves copied, sometimes even at the expense of the organism.
So complexity emerges from this blind process. Okay, the title, The Beginning of Infinity. What's the infinity here?
It's about the potential for knowledge growth. The idea that there's no fundamental endpoint, no ultimate limit to what we can understand and what problems we can solve.
And underpinning this is universality.
Yes, the universality of the laws of physics. A finite set of rules seem to apply everywhere, across all time and space. And humans, because we can understand these laws and create explanations, are universal explainers.
And therefore universal constructors, we can build things based on that understanding.
In principle, yes. We
Oh.
contain the principles of universal computation.
He gives examples of jumps to universality in human history, like alphabets.
Right, a small set of symbols representing sounds, allowing infinite combinations. Or positional notation in arithmetic. Think how much better it is than Roman numerals.
Huge difference. And Gutenberg's printing press.
Another jump. Universal printing, making knowledge replicable on a massive scale. Though its impact was slower in China, maybe because of the writing system's complexity compared to alphabets.
Yeah.
And then Babbage and the concept of universal computers.
And even in biology.
The genetic code, a universal system for encoding life, enabling all the diversity we see.
Okay, but what about limits? Gödel proved some mathematical truths are improvable. Turing found functions that aren't computable. Doesn't that contradict infinite progress?
It's a really important point. But Deutsch argues no, it doesn't contradict the solubility of problems. Gödel and Turing showed limits within formal systems and computation. But even when we hit such a limit, say, failing to prove something mathematically,
We still learn something.
we learn why that approach failed or about the nature of the problem itself. Knowledge still grows. The principle is that for any problem, the right knowledge would solve it, even if we haven't found that knowledge yet, or even if finding it involves understanding these mathematical limits.
So problems remain soluble in principle.
That's the core optimistic claim.
Now, he's also quite critical of bad philosophy. What does he mean by that?
Basically, philosophies that get in the way of creating good explanations, like instrumentalism, the idea that science should only predict, not explain reality.
Just shut up and calculate.
Kind of, yeah. It denies the importance of understanding why things happen.
And the danger is?
If you're not actively seeking explanations, unstated, unexamined assumptions can creep in and lead you astray. His funny example is tracking a spontaneous human creation count, just collecting data without a sensible underlying theory.
Right. And he thinks this kind of bad philosophy has actually harmed progress in some
He
areas.
suggests it has, mentioning things like the Copenhagen interpretation in quantum physics or certain views of human thought, arguing they sometimes hinder deeper understanding by dismissing explanation or objective reality.
Okay, shifting slightly. Beauty. He argues for objective beauty. That sounds controversial.
It is, but his idea is that great art, like great science, adds something genuinely new and valuable to the world, that the standard artists reach for aren't purely subjective or cultural whims.
Hmm. Interesting. And memes, like internet
Well,
memes.
broader than that, units of cultural information ideas, skills, tunes, fashions that replicate by being passed between minds.
And they contain knowledge
Mm,
about how to get themselves copied.
yes, sophisticated knowledge. He distinguishes between selfish memes, which just spread because they're good at spreading, even if they're harmful or false, and potentially rational memes, which spread because they embody truth or usefulness.
And the type of society static versus dynamic affects which memes survive.
Right. Static societies often favor memes that resist criticism. Dynamic ones allow rational memes, good explanations, to eventually win out through criticism and improvement. He warns we might underestimate how many anti-rational memes still influence us today.
And human meme replication isn't just monkey see, monkey do.
No, it involves understanding, interpretation, explanation. We recreate the knowledge, we don't just copy the behavior blindly.
Which raises a puzzle. If knowledge growth was so slow for most of history, why did creativity evolve?
His suggestion is interesting. Maybe creativity initially evolved simply for the faithful replication of existing complex memes and traditions, making sure they got passed on accurately.
Wow, okay. And progress itself.
Yeah.
It's not about reaching some static utopia.
No, it's inherently unstable in a way. Solving problems creates new possibilities, and therefore new problems. It's a continuous cycle of improvement and change. He contrasts this with static societies, like his Easter Island example, that fail to adapt.
Which is why he's critical of pessimism based on finite resources.
Exactly, because that pessimism often ignores the infinite resource. Human knowledge and creativity to solve problems, find alternatives, create new resources. He points to people like Paul Ehrlich whose dire predictions failed because they underestimated innovation.
So progress is moving from problems to better
That's a
problems.
great way to put it, a continuous transition.
And finally, he touches on infinity itself, mathematically, and even the multiverse.
Yeah, briefly. Discussing different sizes of infinity in maths, Hilbert's weird infinity hotel thought experiment, just to stretch our minds about the concept.
And the multiverse.
He mentions it as a potential physical consequence of quantum theory, the idea that there might be countless parallel universes branching off constantly. It's deep speculative physics, but fits the theme of vast, unexplored possibilities.
Definitely a lot to chew on there.
For sure. It's still very much an active area of research and debate.
Okay, so let's try and wrap up this deep dive into Deutsch. Key takeaways seem to be the power of explanation, the need for criticism, the idea that observation isn't simple.
Uh-huh. The universality of physical laws and our own potential as universal explainers and constructors, and this ongoing cycle of problem solving driving progress.
We really hope this run-through has given you, our listener, that shortcut you wanted, hitting those aha moments in Deutsch's thinking without getting lost in the sheer immensity of it all.
Yeah, hopefully it clicked and gave you a solid grasp of these powerful ideas.
So here's a final thought to leave you with, building on that title. If we really are at the beginning of infinity, always at the start line of potentially unlimited knowledge creation, what does that really imply for our future? What possibilities, what challenges does that open up for us personally and as a species? Something to think about.